In this video, I wanted to cover some of the structure and function of the nephron. Now, the nephron is a very tiny microscopic unit in the kidney, and that's where urine is made from blood. What you need is a blood supply then going into the nephron. This first structure here is called the afferent arteriole, which brings blood into the nephron, and then blood exits via the efferent arteriole. So blood enters via the afferent arteriole and enters this area here, which is a tuft of capillaries called the glomerulus. This is where the filter is. The capillaries are permeable and there are some pressures in there, and the net filtration pressure, the sum of the pressures, will push substances out of the glomerulus, and the substances are captured via this tough fibrous capsule called the glomerular capsule, otherwise known as Bowman's capsule. So blood goes in via the afferent arteriole. The blood is filtered here in the glomerulus. The blood exits via the efferent arteriole, and then the filtrate is captured via the glomerular capsule. The filtrate then moves down this tube, and the tube twists and turns, and it's called the proximal convoluted tubule. The tubule is surrounded by peritubular capillaries. So the filtrate moves down this proximal convoluted tubule and enters this U-shaped tube called the nephron loop. The nephron loop consists of two essential parts. There's the descending limb, which is permeable to water. Water is pulled out. And then the ascending limb, where solute is pumped out via active transport proteins. And the solute consists of sodium, potassium, and chloride. This creates what's called a countercurrent mechanism. So water moves in one direction, solute moves in the opposite direction. And what you end up with is a dilute filtrate. So the dilute filtrate then moves through this next portion of the tube called the distal convoluted tubule, and then ends up in this part called the collecting duct. Now, this is also surrounded by peritubular capillaries, and there is substance exchange between the tubules and the capillaries. There are two primary processes here. One is called tubular reabsorption, where substances move from the tubules to the capillaries. The other one is called tubular secretion, where substances move from the capillaries to the tubules. So some substances move via reabsorption, other substances move via secretion, and water moves by osmosis, which can go in either direction. Now, this is important with regard to diuretics. For example, the nephron loop, there are certain diuretics that affect the transport protein in the nephron loop called loop diuretics. They prevent the solute from being moved out of the tube, so the solute moves through the tube and it pulls water with it by osmosis. Other diuretics work in the tubules, and they may, for example, prevent tubular reabsorption of sodium. So instead of sodium being reabsorbed back into circulation, into the blood, it moves through the tubule and it pulls water with it by osmosis, creating a diuretic effect. There are several mechanisms of diuretics. All right, so hopefully this helps with your understanding of the nephron. And I have other videos on the specifics on how tubular reabsorption and secretion works and how the nephron loop works. So thanks for watching and see you next time.